Welcome to this next video in our series on lifecycle management solutions for Oracle products. IKAN ALM starts where the actual code development ends. For each of your projects, it offers the following lifecycle management related services. Setting up the lifecycle. A classic example is DTAP, Development, Test, Acceptance and Production. Build and deploy services and approval services. On top of that, IKAN ALM integrates with third-party versioning systems such as Subversion, Git, CVS, ClearCase, PVCS and Team Foundation version control. It also integrates with issue tracking systems such as Atlassian Jira, HP Quality Center, Microsoft Team Foundation and CollabNet TeamForge. IKAN ALM is environment and platform agnostic. It allows you to manage a variety of project types. You could, for example, manage ODI and OBI as well as Java programs. One of the major strengths of IKAN ALM are the phases, which are used for the build and deploy processes. IKAN ALM phases are predefined parameter-driven, reusable package building blocks. Those building blocks allow you to fully automate your lifecycle management process without having to write any code or scripts. You just need to adapt the phase parameters. IKAN ALM comes with a set of internal phases called core phases. Those phases take care of the basic actions in the build and deploy procedures. They cannot be modified nor deleted as they are an integral part of IKAN ALM. Next to that, RedBridge developed specific solution phases for Oracle products to meet the requirements of developing in an Oracle environment. We have, for example, solutions for ODI, OWB and Fusion middleware. On top of that, you can create your own customized phases to execute specific tasks. Phases are a major asset in the automation of your lifecycle management process. In this video, we will show you how to install IKAN ALM and how to specify the link with the version control repository. Next, we will demonstrate the creation of a project and set up its lifecycle, the build and deploy levels, and the corresponding build and deploy environments. When that's done, we will also show you how to specify the link with an issue tracking system. All that is generic for all environments. Whether you use ODI, OWB or Fusion middleware, the principles are the same. Last but not least, we will briefly introduce the IKAN ALM phases concept, which are the components needed for achieving a fully automated build and deploy process. Let's start by installing IKAN ALM. For this demo, we will use the IKAN ALM Linux demo version. First, you need to extract the tar.gz file. Go to the IKAN ALM demo folder and extract the IKAN ALM trial tar file. Open the extracted folder and next open a terminal window and execute the jar file. The installation process will start. The installation is very simple. Basically, you only need to click Next. First, you select the language that will be used during the installation process. Next, you will be forwarded to the README file, accept the license agreement, and click once again Next. By default, the installation path is set to /home/ikan/ALM demo. If required, you can modify this location using the Browse button. When done, click Next to continue. All installation packs must be installed, so simply click Next. On the following screen, you need to select a Java development kit. Note that a version 1.6 or higher is required and that a Java runtime environment will not be sufficient. When done, click Next. Normally, the default configuration parameters should be okay. Make sure that the port numbers are not already being used by other processes. Click once again Next and you'll see an overview of what has been installed. If everything is okay, click Next to start the installation. Once the installation is finished, you can create a shortcut and a program group. Click Next to complete the installation procedure and click the Done button if you do not want to generate an automatic installation script. Before launching the application, we need to start the application server. Go to Applications IKAN ALM Demo 5.6 or the name you entered during the installation process and select Start IKAN ALM Demo Server. Open a browser window and enter the URL. This is composed of the machine name and port number followed by /ALM. The logon screen will be displayed. If this is your first installation, no license will yet be installed and you will be prompted to enter one. A license file is provided with the IKAN ALM demo installation. Click the Browse button and select the license file from the IKAN ALM trial folder you unzipped at the beginning of this installation procedure. Click Submit and log on using your username and password. For the demo version, you can use the username global and as password global as well. Let's first verify what has already been set up automatically in the IKAN ALM Global Administration. And select System Settings from the submenu. On this screen, you will see the build archive location on the IKAN ALM server. All the build artifacts will be stored here after a successful build. You will also find the paths to the other locations needed by the IKAN ALM system. For more in-depth information, you can consult the IKAN ALM user guide, which you can download from the IKAN ALM website. On the machine's overview window, you can find the definition of the IKAN ALM server. You should also have an agent installed on this machine, and both the server and the agent processes should be running. You can verify this by clicking the Installed Phases link on the overview. This will direct you to the overview of the installed phases. The current server and agent activity is shown in a separate column. Both should show the green icon status. Something else worth verifying is the scripting tool. You can do this by selecting Scripting Tools overview in the submenu. Before we can actually create a project in IKAN ALM, we need to define the connection settings for Subversion. Go to Global Administration, Version Control Repositories and select Create. In the Type field, you select Subversion from the drop-down list, and as a result, the Subversion Connection Details panel will be displayed. First, we now enter a name for the Subversion definition and a description. Some other important fields to fill out are the command path, which is a path to the location where the Subversion client command resides, the user ID and password, the URL of the machine hosting the Subversion repository, the repository layout, in our case we choose single project oriented, and the timeout value. Before creating the repository, you can first test the connection. Next, confirm the creation by clicking the Create button, and the repository definition will be added to the repository's overview. Now we are ready to create a project. On the main menu, you select Project, Create Release-Based Project, enter the name and a description for the project. The VCR project name doesn't need to be filled in, as this is not necessary for single release-based projects. Next, select the version control repository we created in the previous step. Specify AND as the build and deploy tools type, and enter the build prefix. There are more options you can specify, but we will not go too far into detail in this demo. You can find the full explanation of the different options in the IKAN ALM user guide. Confirm the creation of the project, and we are ready to define our project's lifecycle. On the project overview, you click the Edit icon in front of the demo project we created. Next, we go to Lifecycle Create. A lifecycle defines the logical step at the moment you create a project. The base lifecycle, which is linked to the Subversion trunk, will be automatically created. This lifecycle will be used for ongoing development. The logical steps within the lifecycle are called levels in IKAN ALM. 3 different level types can be connected to a lifecycle: build, test, or production levels. At least one build level must have been assigned to a lifecycle before you can create any level request for the project stream connected to that lifecycle. To create a build level, you click the Create Build Level link in the Build Levels panel. Specify the name and description, and check the Debug option. Activating the Debug option leaves the work locations intact, which makes it easier to track things in the beginning, in case a build fails, for example. Once everything runs smoothly, you can deactivate this option, and from then on the work locations will be cleaned up. Fill out the other fields and click the Create button. We are now back on the lifecycle overview. Our build level has been added to the Defined Levels panel, and now we can define the required deploy levels. To do so, use the Create Test and Create Production level links. The number of test and production levels in a lifecycle is unlimited. The creation of those levels is very similar to the creation of a build level. The result should be similar to this one. We have now 3 deploy levels, 1 for test, 1 for acceptance, and 1 for production. Before we can start working with our project, We have to define the different build and deploy environments. The build environment is a physical location where the code, retrieved from the VCR, is built. It must be assigned to a level in order to become active. The creation of such an environment is done on the Create Build Environment window. The most important fields on this window are the name of the environment and the source and target locations. The sources we want to build will be transferred from the version control repository to a subdirectory of the source location. The results will be placed in the target location. You are free to specify those locations. You can also make the builds downloadable. Activate the debug option. As said before, until everything runs smoothly, it is recommended to activate this option. Specify the level you want to assign the build environment to, select the machine to which it must be related, and select the build tool. When that's done, confirm the creation. Next, you should create a deploy environment for each of the levels. Deploy environments are locations where a deploy tool uses a deploy script to unpack and deploy a build result. Just as the build environment, the deploy environments must be assigned to a level. The definition of the deploy environments is similar to that of the build environments. Select Create from the Deploy Environments submenu and fill out the fields. You repeat this process for each of the deploy environments you need. The final result will look similar to this one. We have 3 deploy levels: Test, Acceptance, and Production, and each of them is linked to a deploy environment. The IKAN ALM issue tracking functionality provides the possibility to link issues from an external issue tracking system to an IKAN ALM level request. This can be done automatically by doing a search for handled issues in the comments that developers provide when committing or checking in their sources into the VCR, or you can add it manually to a successful level request. For this functionality to work, you first have to define the issue tracking system in IKAN ALM. In the Global Administration section, you select Create Issue Tracking System from the Issue Tracking submenu. Enter the name and the description. Next, select the name of the class that must be used for the issue tracking system. In the URL field, you enter the template URL that will be used to click through from an issue in IKAN ALM to the issue in the external issue tracking system. Next, enter the username and password. And specify the issue pattern. This must be a valid regular expression. This pattern will be used to detect issue numbers in the commit comments in the version control repository. You should also specify the issue ID pattern. This pattern is needed to retrieve the exact issue number out of a matched issue in the commit comment. It's part of the issue pattern and must also be a valid regular expression. Next, select whether you want to automatically add a comment to the issue in the issue tracking system. This comment will contain a link to the IKAN ALM level request. This was a very quick explanation. For more details, please consult the IKAN ALM user guide. Everything is now ready to start working with IKAN ALM. Our final goal is to automate the build and deploy processes. That's where the IKAN ALM phases come into the picture. As we mentioned in the beginning of this video, there are 3 types of IKAN ALM phases: core phases, specific solution phases, and custom phases. Let's for example have a look at the build levels phases. Via the levels overview, you can display the default level phases by clicking the Edit Phases icon in front of the level. By default, the build level uses the following core phases: the Retrieve Code phase. This is usually the first phase executed in a level request. It retrieves the source code from the VCR and copies it to the work copy location where it can be picked up by the agent running the build level request. Next you see the actual build phase, which activates and monitors the execution of the build of the level request. The tag code phase will tag the checked out code with the VCR tag associated with the level request. Then follows the deploy phase, which activates and monitors the deploy of the level request. And finally, the work copy will be cleaned up. Those are the default building blocks of the build process. Phases can easily be inserted or removed from the process, depending on your requirements. For example, you could add a phase to stop or start an application server. For the build and deploy environments, IKAN ALM also offers a set of core phases. Here the same principle applies. You can add your own customized phases or add our specific solution phases. RedBridge has developed dedicated solution phases for Oracle products. For ODI, there are, for example, 3 solution phases. 1. To execute the build process. It will retrieve the objects or scenarios out of the VCR and put them in an archive for further deployment use. The second one deploys the archive, namely the objects or scenarios, to an ODI repository. And the third solution phase allows creating ODI repositories. Those ODI solution phases will be treated in the last and certainly most interesting video on RedBridge's LCM for ODI solution. For more information on our company and products, we invite you to visit our website. If you would like to discuss any specific requirements, you can always contact our ODI specialists or participate in one of our webinars. Every Tuesday, we organize 2 webinars. The first one at 10 a.m. and the other one in the evening at 7 p.m., both Central European Time. After the demo, we will take the time to answer any of your questions. Thank you for watching.